we are going to be talking about production planning and modern options for this, because from my point of view, and I can confirm this from real life, production planning can become a competitive edge. And this is what the next presentation is going to be about. And let's listen to the presenter. This is Markus Gunther, CEO of Inform GmbH, and I'll hand over to you, Markus. And if you like, of course, ask your questions via Slido. Right, thank you. I'm glad you're here today. I'm glad that you're interested in this particular topic. And I would like to ask the half hour to give you some kind of impetus on production planning, how this can become a competitive advantage. So most of you probably face the challenges of production planning. In mechanical engineering, this is high part diversity. So you've got many part families, many data, high circulating stocks, and so on and so forth. And this leads to a situation where you have very complex planning processes, where you have to have alignment between the different areas and departments. Then you've got varying throughput times, and so on and so forth. And this is reflected at the end of the day in what you offer to your customers, which is a varied production range. And as if this wasn't hard enough, because things go wrong, there are numerous disruptive factors that will mess up your planning: delays, resources failures, migrating bottlenecks, late purchases of materials, or people calling in sick. And this is what we're going to be talking about today. Now, when it comes to production planning, the answer is often, well, that's what I have my ERP for, enterprise resource planning. But as you will know and will have noticed, in real life, ERP planning has its limits. Almost exclusively, ERP programs have plans, unlimited capacities. They have only a restricted material availability check. They do their planning into the past. And if you have to reschedule, this requires a lot of manual effort. And in addition, particularly when you're talking about production networks that go across different countries, cross-plant production is very difficult to map with an ERP system. So what can we do? You can have a modern production planning tool with the help of AI. And in order to see where the added value actually is, let's start with the picture how it is for the different companies. You start off with an Excel sheet, with an MES system, and once you've seen how that works, you can see what the artificial intelligence can do, and then, of course, you will know what the competitive advantage is going to be. Very simple example, we have 6 workstations in 3 areas. We have 3 manufacturing jobs, A, B, and C. A is the most important one, B the second most important one, and 3 the least important one. And you see the jobs going through production. Order A needs to go to workstation 2, and then to 3, and to 5, and the other ones in analogy to that. Just in order to go through this manually, we said per day and workstation, 1 working step can be dealt with. In addition, sales and assembly wants all those jobs concluded after 3 days. So in an ERP system, they would have the same deadlines, and there will be some degree of challenge regarding planning. And now, let's look at the entire scenario if you have a local MES, Excel, or something else. So, let me put on the hat of the supervisor of workstation 1, and let me determine what I'm doing on day 1. The answer is fairly quick. There is just one job that's very important, so job A has to be done first. Workstation 2, okay, this is a challenge because I have to decide whether job B or C has to be done first. The same deadline. B is a bit more important. I assume that the supervisor wants what's best for the company, so job B will be done on day 1 and job C will be done on day 2. Now let's move over to the manufacturing area 2, workstation 3, the next decision. We wonder, well, what needs to be done first here? Job A or B? Job A, of course, is the prioritized one, so we'll do that one first. But we can't really do anything more on day 2 because the processes haven't been concluded. Then day 3, there has to be no planning. Job A needs to be concluded and B and C need to be continued. Let's go to production area 3 and workstation 6. Now, once again, the question, what do we do next? B or C? And here, once again, well, it's the same deadline. The job B is more important, so we have to finish that first. And then on day 5, we'll conclude job C. So, what does that mean? First of all, everyone did what's best according to their opinion, and the bottom line is we have a machining time of 12 days, 3, 4, and 5, and an adherence to deadlines of 33%, because only one job was finished on time. So the supervisor goes home with a clear conscience because he or she did what was best for the company, but sales is probably a bit dissatisfied because the adherence to deadlines wasn't complied with. So what can we do? What can we provide for you to get better? So let's look at the exact same example once again and look at the scenario with an AI assistant. So let's ask what's done in workstation 1. Quite clearly, it needs to be job A. Artificial intelligence wouldn't change anything about that either. But now it's interesting. Workstation 2, artificial intelligence would say, well, do job C first. It's a bit counterintuitive because job C isn't as important as job B. Why does artificial intelligence decide for that? Well, it can look ahead and knows that if you did job B on the first day, then on the next day it would have to wait for job A. So it doesn't make any sense to start with job B. So job B would be done on the second day. On the second day, we would also continue with job A and C in order to, on the third day, conclude A and C, continue working on B and concluding B on day 4. Looking at the bottom line, we have a machining time of 10 days. It was 12 before, and we have concluded 2 out of 3 on time. So this was no cheating. We didn't create any additional capacities. We only did what's best for the capacities that we have, switching from a local to a global view with the help of artificial intelligence, looking at bottlenecks proactively, avoiding these bottlenecks and making sure that this just runs more smoothly through your production. I can see from your looks that if you look at this very simple example for 30 seconds, then of course you could also do this without artificial intelligence. And I also assume that you have more than 6 workstations and more than 3 orders. And now this is where it gets interesting. Once things start looking like this, and this is a realistic scenario, you've seen what the artificial intelligence decision has brought about in terms of a result. Now imagine this scenario and the potential that's in here to get better. So we have a supervisor who's working on machine 4 and needs to decide the order of jobs. He doesn't have an opportunity at all to do this. He will have to know whether somebody has vacation on machine 13, whether machine 12 needs to be maintained. There are so many things that come in here, so many factors, and only with human planning, this will just be too difficult. And once it reaches that degree of complexity, artificial intelligence can really unfold its full potential. And then you can think one step further. If you're not only producing in one plant, but if you look at the complex example that we looked at before, and if you have several plants with complex structures where you have bought-in parts and assemble these in another plant, then in addition you have more bought-in parts, and then all of a sudden you've got a degree of complexity that an Excel sheet or a scheduler, even with the best experience, will not be able to handle just because of the sheer volume. And the ERP providers always have a little bit of a trap in store for us, because when planning across plants, there are quite a few challenges commercially, and often you have the case that bought-in parts from another plant are dealt with in exactly the same as by third-party suppliers, and this just changes things in the whole scenario. And this is something that you can involve in AI-based production planning. So the heading of today's presentation is how production planning can become a competitive advantage. And we can think about this together and be clear of what this actually means. So first of all, the very evident benefit from an AI-assisted production planning is that you minimize your expenditure, your effort. This is something that the system does for you. You saw with a small example, throughput times are shortened and circulating stocks are improved. These are the very evident, obvious facts. Then you have higher adherence to deadlines. You had the percentage coming from 33% to 66%, and the algorithms also ensure that the available resources can be handled with maximum efficiency. So those are the effects that you can take away from the examples that we've seen already. And if you think of this, nobody will be against any of these competitive advantages, because it's not only a competitive advantage, but also a financial advantage. But of course, you can go one step further, because these are only the very obvious effects that you would bring about immediately. But going one step further, once you've done all that, what does it mean? What's behind it? What are the effects? Then you've got shorter delivery times. Because of these shorter delivery times, you've got a better market position. You've got a higher customer satisfaction, because you can deliver more quickly, more reliably, more efficiently. And I'm sure, once again, that all these are effects that nobody of you would not want to have. And this is another advantage, a competitive advantage, but also a financial advantage. And then, going one step further than that, if you think about the follow-up effect once you've done all that, because of my better market position, because of the higher customer satisfaction and the shorter delivery times in a very severe field of competition, you can get new customer orders, you can get follow-up orders, and of course it's also the basis to grow your company, because once the company can grow, once you have new orders, the company can grow. So on the basis of AI-assisted production planning, all this can be done. Now, once you've reached that stage, you've got follow-up orders of the existing customers, you've got new customer orders, and all the challenges that we saw before are going to become even more complex. You'll have more orders, more arrows going back and forth, and then at the latest, once you have been happy about all the financial benefits, it's really essential that you have a good production planning system, because otherwise you won't be able to implement the new orders on time, and so the wheel continues to turn. Production planning is so central for you, your market position, that all these effects can be implemented quite simply by doing it just the way that I just outlined. Now, there's a second aspect that I'd like to address, another AI topic in interaction with production planning. What's essential for production planning is the interaction between purchasing and production. Because if you have no parts, the wrong parts, then production planning has even more challenges than it has anyway. So we need a good production planning, reliable procurement dates, because they form the basis for good, stable production planning. Now, you know the challenges surrounding procurement, time and again orders arrive later than planned, causing disruption to planning, or orders arrive much earlier than needed and result in full warehouses, capacity constraints and tied up capital. Why is that so? Well, in practice you will have experienced this time and time again. There are lots of suppliers who have a standard delivery time. Sometimes it fits in with your schedule, sometimes it doesn't. So there will be a lot of disruption in your production planning because of that, because you don't know exactly when production is going to start. So what can you do about this? How can modern systems improve this? Let's have a look at this. So you've got the topic of replenishment time. In an ideal world, it would be that you've got an ERP system, you've got 14 days replenishment time, and the actual delivery time is also 14 days. That would be the ideal scenario. So this would look like this. It would be a diagonal. The parts would arrive just in time, taking into account the replenishment time. Now, we've assessed this for a customer, and the actual scenario looks like this. Of course, there is you see a lot of scatters on the diagonal, but there's also a lot of scatter beneath and under that. You've got the things underneath the diagonal, things arriving too early, so that you have too many stocks, too high a inventory, and tie up your capital. And everything that's left of the diagonal, where the delivery takes longer than it should, are even worse. You've got a disrupted planning, and you have to move around your production, and you've got some emergency actions, and I'm sure you know all these cases from practical scenarios. So this is the challenge. What can you do to address this particular challenge? Well, all of you have something that's very valuable, your data. In your ERP system, you've got a long history of orders, so you can see how your suppliers delivered, whether they were too early or too late, and you could just go there and calculate an average factor, but it wouldn't be really up to the problem. So what else can you do? You can take your data from the historic data, and with the help of machine learning, you can detect certain patterns. You can see, well, supplier A wants to ensure that in the summer some parts are delivered. These parts will always be delivered late. And this is something that you can find from the data. And what can you do with this data? Well, you can set up a prediction model, not looking at replenishment time from 14 to 17 days, which wouldn't be that much of an improvement. But for every order that you have, you could calculate if a supplier acts like he did in the past, then the possible date of delivery would be this one. So you've got a decision tree, you've got the input parameters such as what supplier are we talking about, how big is the order, what did I order, what's the value of the order, and so on and so forth. You remember the picture of the diagonal. So what could this look like? And these are real data from a customer. You see the additional orange points now, and the orange points are predictions on the predictable delivery date. They are not exactly on the diagonal. I mean, artificial intelligence can't do magic either, but you can see that these orange points are much closer to the diagonal. And wherever you had these extreme situations depicted by the green points, these scenarios can be eliminated, and the negative effects connected to that can be avoided too, because artificial intelligence will predict how your supplier is going to behave. So you can see that quite well in the image here, but it's often also good to see hard facts, and we divided this in 11 customers. We took real live data and looked at the average deviation from delivery date and ERP deadline and forecast of the AI, and it's a bit different depending on whether you have certain requirements, an unconfirmed order or a confirmed order. And the values you see are really quite positive. So on average, our deviation has improved by 21% for ERP order requirements. For the unconfirmed orders, it's a bit lower, and for the confirmed orders, it's a bit higher. But there were also customers, as you see on the right-hand side, maximum improvement, where we had 36% or 42% improvement, where artificial intelligence predicted much more precise deadlines. So the artificial intelligence was smarter than the suppliers when telling you when their dates would be. And this doesn't mean that you have punctual deliveries, but you are forewarned. The system will tell you, the supplier said the parts will be there on the 5th of August, but this is not going to be true. And this will help you at the start of production planning to have more reliability in the system. Right, so these were the two bits of inspiration or incentives that I wanted to provide. And just out of curiosity, I thought it was interesting. Where are you in your production planning? Do you do this with experience? I mean, there are people, seasoned people, who know that when a certain part has to be delivered, then it's got to start with X, Y, Z, then, or do you have AI-assisted production systems already? So I would ask you, who's already planning with an AI-assisted software? Hands up. Well, okay, the moderators are excluded, but I've noticed that with pleasure, but I always ask, and the answer is usually there's very few. Who has an MES or ERP system? Most of you. And who does it with a sort of gut feeling and out of experience, human expertise? Okay, just a few of you. Right, so we did a survey, a large survey, because, you know, these answers are never really representative. In February 2024, we asked 237 companies, and the result was that 70% said, well, they do it on the basis of experience. 79%, the overwhelming majority, said, well, we do it on the basis of Excel and MES systems. And only 3.7% said, well, they already have AI planning software. And what you see is, I mean, you saw the competitive advantages that are possible with AI. This is where we stand. So with what's possible today, we have a lot of room for improvement for the manufacturing companies. Right, so I'd like to sum up what the core messages of my presentation are. You saw that optimized production planning is a decisive competitive advantage. By using AI, this will improve your core KPIs, adherence to deadlines,
throughput time, inventories, and what's most important really, almost all the data you need is already there. So this is an effect that you can have straight away. Usually when it comes to AI topics, you need to think about whether you have the data, but the ERP system usually has all the data you need, so you can start without any further ado. This is not at the research stage or at the prototype stage, but we've done this with a lot of customers. This is just a small excerpt. We have about 300 companies who are using this already, and most of them are from mechanical engineering, plant and mechanical engineering, small series production. And I'm sure that you know some of the logos here. Some of the exhibitors are also among them. And apart from these references, I've just picked out 2 or 3 examples of what individual customers say. Stiva from Austria, for instance, said that adherence to schedule, which was 70%, was increased to 90% permanently. And parallelly, standard throughput times were decreased by 5 days. So these effects are not only theoretical, but they actually occur in real life. Or the Kraus-Maffei company managed to reduce their circulating stock by 15%, and they could handle the complexity in production much more. So this is something that everybody will probably want to have. And then the company Achenbach-Busch-Hütten, this is a great example. If you have the same employees and the same surface, the same space, by optimized production planning, you can have 30% more sales because you could have a much more efficient production. So as you saw just now, AI is forward-looking. It's an early alert for the challenges that you will probably have to face. That was what I wanted to say. We are the Inform company. We are a software company from Aachen. We not only do production planning, we solve all the logistics problems that come up. We have 1,300 staff, and you see on the upper left-hand side what I mentioned today. So we have 24.2 million of working steps that are planned on the basis of our model, on our system, and very many mechanical engineers have already benefited from this. Okay, so you now have the opportunity to ask your questions. Thank you very much, first of all, for this very good presentation. We don't have that much time left, but I was totally surprised. I mean, if you present an artificial intelligence solution as an external party, you think, well, it could only be 2 or 3 years on the market. But you've been around for much longer, haven't you? Answer, well, the first evolutionary stages of this was 30 years ago, but of course this was a completely different scale. The computing power wasn't that big back then, so there were simple rule-based systems, got more and more intelligent, more and more complex, and because of the evolution of computers, the bigger production scenarios were included. You can look at 4 or 5 different plants with millions of working steps and schedule them accordingly. And 10 or 15 years ago, this wasn't possible, of course. Let me just correct this. The moderator owns a manufacturing company, and that, brings us to the trying out stage. So another big hand for this wonderful presentation. Have you told people where to find you? I had a slide, Hall 6, booth B36. We've got a wonderful booth there with a partner company, and we're looking forward to seeing you there. We can talk about this live and you can look at everything. Okay, right, so big recommendation. Thanks so much for the presentation. Mr. Günther.